we focus on energy from combustion. Hydrocarbons, 6.1, encompasses hydrogen and carbons coming together to make organic compounds. So what are fuels? Well, fuels are any solid, liquid, or gas that can be combusted or burned to produce heat and energy. Fossil fuels are, they're formed millions of years ago using remains of ancient plants or animals that are buried deep down below the Earth's surface to produce coal or oil, natural gas formation. So here's an example of a endothermic process, which we'll talk about later. But here, photosynthesis, where plants use CO2 and water and energy from the sun to give us glucose and oxygen gas that we breathe in, essential for life. We have something called an exothermic reaction, where energy is released, and we'll talk a bit about this later, where we take food, we breathe it in, oxygen to give us CO2 and water. And I'll let you guys use your balancing equation skills to check if these equations are chemically balanced. So in order for combustion to occur, we need three things. We need a heat source, we need some fuel, hydrocarbons, and an oxidizer. The majority of the time, this is oxygen. And the fuels for our class that we're going to focus on are hydrocarbons, again, containing hydrogen and carbon atoms. So a little bit from Lewis structures that we've already talked about. Carbon should always have 4 bonds. So if you look at these carbons, each carbon has 4 bonds connected to it. They should have 8 shared electrons. So remember, each bond is 2 electrons. So this carbon has 2 electrons to the left, above, to the right, and below. And we sometimes use double and triple bonds to indicate, to make this 8 electrons around the carbon. We've talked about Lewis structures, how they can represent carbons and hydrogen bonds. Here is an example of a condensed form where we just show the carbon connections down here. And we also have a skeletal form where each point, there's a carbon here, there's a carbon here, a carbon here, and a carbon here. 4 carbons in this compound called butane. Well, naming hydrocarbons is important for us. If, for instance, if there's 1 carbon in your structure, we use the word meth. If there's 2 carbons, we use eth. 3 carbons, prop. 4 carbons, bute. 5 carbons, pent. 6 carbons, hex. 7 carbons, hept. 8 carbons, oct. 9 carbons, non. And 10 carbons, dec. And the ane means that they're all single bonds. So in this example, we have the combustion of C4H10, which is butane, 4 carbons meaning bute. And this reacts with oxygen to give us CO2 and water. So whenever we have a combustion reaction, you need oxygen, O2, and the products are carbon dioxide and water. And the amount of energy that's produced depends on the amount of hydrocarbon, the amount of oxygen, and their ratios in a chemical reaction. So let's try one of these. It's asking us for each of the fuels below, write the balance combustion reaction. We'll do one together. I'll do the simple one for you first. We have C4, which is methane, plus O2. We can remember a combustion reaction involves oxygen, giving us CO2 plus H2O. Okay, and if we were to balance these, we notice there's one carbon on the left, one carbon on the right, so we can keep that the same for now. We look at the hydrogens. There's 4 hydrogens on the left and 2 hydrogens on the right. So how do we make 4? We put a 2 here, and now this becomes 4 hydrogens because 2 times 2 is 4. What about the oxygens? The oxygens on the right, there are 4 oxygens, 2 from the CO2 and 2 from the water. And on the left, we have 2 oxygens because of the O2. So how do we balance this? We would put a 4 in front. Okay, so this is how we would balance the combustion of methane, CH4, so the coefficients would be 1, 4, 1, and 2. And I want you guys to try the combustion to write a balanced chemical equation for sugar, C6H12O6, and butane, C4H10. Remember, oxygen as a reactant, O2, and the products will be CO2 and water.